Welcome to the Tall and Urban podcast by the Council on Tall Buildings and Urban Habitat. This is Daniel Safarik. This is Season 1, Timber Rising, sponsored by the USDA Forest Service. We're talking with leading experts about mass timber, a way of building with engineered wood products that is gaining traction around the world. Today we're talking to David Barber, Principal in Fire Engineering at Arup in Washington, D.C. David, welcome to the podcast.
Thank you very much for asking me to participate.
So I would like to ask you today about the general obstacles to the adoption of mass timber as a construction material when it concerns the issue of fire safety in tall buildings, which is obviously very important. And I think probably the first thing to illustrate is the difference between mass engineered and traditional wood framing, and how do these perform in fire comparatively speaking?
Typically we see mass timber as sort of this collective term for the larger engineered timber materials. And we've got regular timber framing, which we see in typical housing type construction with 2x4s and 2x6s and those sorts of things. And in some ways, all of those timber materials have the same properties. In some ways, all of those materials are different parts of a tree, but they all carry that same form of the same fiber structure. They all have the same strength properties when we look at them sort of at a very micro or macro scale, and it's just a question of how much we've scaled them up and how much we've sort of engineered them to use them in a way, if either as a beam or a column, potentially as a floor system. And what differs from a fire point of view is the fact that what we want to be able to do is allow the timber to have its natural performance in fire, and that's the fact that when it is exposed to fire or a high temperature, it starts to char, and that char, it provides a protective layer to the timber. And of course, at a small scale, that charring doesn't really have a great deal of impact. But on a larger scale, when we're talking members, larger timber members, which may be 1.5 foot or 2 feet wide and by 2 or 3 feet wide as a column and a very large member, we've got a lot of structural mass there, a lot of volume of the timber, and so we can use the charring to help slow down the fire ingress into the actual timber and use that as a protective material. So in some ways, engineered timbers and mass timbers like glulam and CLT, we can design those to have a level of fire resistance. So we can actually just to ensure that they have a calculated resistance to match what's needed from the building code. Smaller timber frame elements, they certainly have the same sort of properties, but they're very small. Their fire resistance as such, is very small. It's measured sort of in minutes. And for them to achieve a greater level of fire protection, we typically put something else on those, like drywall, like fire-rated chipboard type materials, because we need them to have a greater level of protection than what the actual individual member can actually provide.
Right. And I think it's those inherent properties of the larger scale timber elements that are being advocated by, shall we say, tall timber enthusiasts, as a structural material that could be considered from a fire avoidance or fire deterrence standpoint, at least equal to, if not superior to, steel, and in some cases equal to concrete. Would you push back on that, or are there limitations to that assertion?
What we are required to do by building codes is achieve a certain level of fire resistance for a building, and typically fire resistance levels increase with increasing height, or often with increasing populations. So such larger buildings like airports or theatres or convention centres will have maybe not very tall, but they're very high occupied, so they have higher fire resistance ratings. And then obviously a 30-story building would have a higher level of fire resistance rating than maybe a 4-story building. And so the building codes treat materials like that, and the basis of understanding how the fire resistance is achieved is through a process of standardized testing. And it's the same test which is carried out for concrete or steel or timber. So you have to then test the material to that actual test. You're loading it, you're exposing it to a certain type of fire exposure, and it's exactly the same type of fire exposure, and you're then determining how strong or how weak that material is based on that exposure. And then once you've understood that, if it fails, you can then work out how to protect it, which may well be by adding some protective material around it, or potentially increasing the member size to be able to achieve the level of fire resistance that you need to achieve. So part of it for me is not that one material is better than the other. It's understanding their weaknesses or their strengths and being able to design to those to achieve what you need to achieve to be able to get your building to stand up and, you know, obviously meet the appropriate building and fire codes.
What needs to happen with the municipal building codes that we currently have in place in order to safely enable more tall timber construction?
A building material which is historically very well known. We've had, you know, timber, mass timber type products around for certainly for a very long time, and they're starting to be pushed into a different direction. So, you know, glulam beams and columns. Glulam is a material which has, you know, been around for over 100 years, and we've been using it in low and medium rise structures for a very long time. We're now wanting to use it in a building which is maybe 20 stories tall. So we're taking those materials and using them differently. And the question is understanding what are the potential weaknesses of those, and understanding, do the current test methods, are they appropriate to be able to use this material we understand in a different way? And it's a matter of working through those aspects, and the code change process often is not as quick as people in the industry would like. But I think certainly here in the US, there has been some very good recent changes, and the 2021 version of the International Building Code, which is the national model code for the whole of the US, will actually allow mass timber construction to be built up to 18 stories, which is a significant change, because this is a technology that developers want to use, architects want to use, building owners want to use. There's a desire for more sustainable construction as well. And so, you know, those are the sort of pressures and enablers which go on that mean that, you know, code committees need to look at what they're doing and start to make those changes. So I think we are seeing some progress. I think we'd all like to see it often quicker, but we do need to understand that there has to be a certain amount of checks and balances that go into building codes to allow you know, building construction to be built.
You've got an upcoming paper in the CTBUH journal where you've written, exposed mass timber in a fully developed fire has been explored through full-scale fire testing, but only in compartments of up to 90 square meters of floor area. Why is that an important distinction, and what more needs to be done?
Yeah, it's a really interesting topic, and it's something that I think at the moment there is a significant amount of very good research going on, and there has been in the last sort of 5 to 10 years, and across a number of different countries, looking at the impact of having exposed timber, so the exposed structure of the timber, and how that impacts a potential fire that may occur. And the reason this is important is because, you know, timber is combustible; it will actually burn, as opposed to concrete and steel, and we know that it burns. We've always known that, and so the question, you know, from my point of view and from others, is yes, it's just another engineering problem we have to solve, and that's the way we look at it. So we know that it's going to burn. We know that we have a whole lot of parameters in the way we can predict how fires will burn in a compartment, you know, whether that be, say, a residential unit like a one-bedroom apartment, or whether that be maybe an office floor, and we know how they perform where we've got a steel or a concrete structure, and we've got, you know, some good validated information on that. But this is slightly different, because if we have the same sort of situation, you know, the actual structure as it burns will actually contribute to the actual the fire itself, because as the timber is exposed to fire, the actual cross section, if you can, as we talked about earlier with the charring, it actually is converting that mass of the actual timber into some actual heat to the fire. So the solution to this is doing some large scale testing, and large scale testing is where we actually set up, you know, a whole sort of residential apartment. We set it up with the appropriate fire loads that would be in a typical residential apartment. We have the exposed timber that's set up like a residential apartment, and we actually set fire to it, allow it to burn, and observe and witness what actually occurs. We record temperatures, we record how the fire grows and decays, and understand that. And the biggest apartment fire we've had as a demonstration and research test has been here in the US, which was, as I said, just on 90 square meters. But we haven't had any significant testing carried out on larger compartments set up as offices. And so an office is quite different to a residential apartment. But as engineers, we like to design with knowing what the outcomes are. We want to design in a way that is conservative and practical, and we want to design in a way which ensures that we get the most appropriate building outcomes from a fire safety point of view. So those larger scale tests certainly are needed. And again, one of those many aspects that we need to understand as we understand how we model these types of fires, and how we want to carry that through into determining fire safe structures for any sort of material, but also importantly, obviously, where we do have the timber exposed.
Well, I really want to thank you for participating in the inaugural timber-focused Holland Urban podcast from CTBUH.
No, thank you. It's great to be part of, and thank you very much for asking me to participate.
Thanks again, David Barber from Arup.